We've recorded some data for a period of time, approximately a week and a half, and we went to the site, offloaded our data, and now we want to have a look at what that data looks like. So we have the dissolved oxygen data offloaded, and we're in the plot setup screen here, and we're going to run the dissolved oxygen data assistant to post-process this data to get the adjusted concentration. So let's click on process, and we'll see here's our dissolved oxygen data assistant. We don't need to adjust for salinity. This was fresh water. I'm not going to get percent saturation, so I don't need to put in the barometric data either. I do want to create a new series called dissolved oxygen adjusted concentration. So that's what we're doing over here. We're going to put in we're going to use dissolved oxygen meter readings to calibrate our data. Basically, what we're doing is we're removing any drift from fouling. That's the idea behind doing this. Our starting calibration point, I'm going to leave that unchecked because this was we just calibrated at the factory, and we knew it was pretty it was nice and steady, nice and clean, brand new sensor cap. But we are going to put an ending calibration point in. So here's all our data points from our deployment. We deployed the logger on the 30th of August, and we read it out on the 10th. So I'm going to use the last recorded value, which it was at 1 p.m. on the 10th. And we want to put in we had a meter, an Orion 5-star. It's from Thermo Scientific, and it's a calibrated dissolved oxygen meter, and our value was 8.49 milligrams per liter. We put it in the water right next to this logger and let it stabilize for a few minutes. And now we're going to click on Create New Series. So now what we see is we have our raw dissolved oxygen concentration. We have our temperature that was recorded. And again, we can display it in US or in Fahrenheit or Celsius if we want. DO, we can show it in parts per million or milligrams per liter. And here is our data series that we created with our post-processing DO adjusted concentration. So let's click on plot. So here is our data over that time period. The blue is our temperature, so we can see how it changes each day based on changes in temperature in the air. One thing that I want to call your attention to is we can see at the beginning of the deployment our dissolved oxygen, our raw dissolved oxygen, and our adjusted concentration. They're reading extremely close to each other, in some places exactly the same value, but as we go along they separate a bit. That's an indication of fouling from it's biofouling. So we were getting some slime on there from the pond. There's a lot of organic material in that pond. So that's what this is indicating. So doing that field calibration corrected for that that fouling. And when we pulled the logger out, we cleaned it and we put it back in. We left the loggers logging. We'll read them out in another couple of months to see how our long-term data was. But for right now, this is just an interim readout. Make sure everything's working okay. One thing we can tell from this data is it looks like this habitat for fish is fine. We were around 10 when we started, and as we're going along, we can see our temperatures going down. But we're still 8.5, a couple of small excursions downward. You'll notice there's a spike right here. We can put in a crosshairs right there. And we can see it went down to about 4 milligrams per liter. I looked at the historical weather data, and that corresponds to a rainstorm and also kind of a dip in barometric pressure. So that could have explained this dip here. But it recovered nicely. It was no problem. The other thing too is you see a little spike right here. where it goes up to about 11. And this corresponds to a very windy day. The day was very, very windy. There was gusts to 30 miles an hour. So that could, and again, there was a change in barometric pressure. The pressure was quite high that day. So that could be affecting this DO level as well. But for the most part, this habitat looks pretty good for our fish. We've offloaded the conductivity logger also, and now we're going to post-process that data using our conductivity assistant in HOBOware Pro. You see here we had selected both the full and the low ranges to record in our data file when we set up the logger. Now that I've looked at the data, I can see that we didn't really need to look at the full range data, so I'm going to turn that off and just look at the low range data for clarity. We don't care about our internal events for this exercise. And now we're going to process this data using the conductivity assistant. We're going to select low range here up in the upper left to do our post-processing. This was fresh water, so we want to use the nonlinear natural water compensation per EN 2788. We do want to create a new series called specific conductance. We want to see what that specific conductance is. And we want to use measured points for calibration. Here we had that Orion 5-star meter that measured dissolved oxygen and conductivity from Thermal Scientific. So we did do a measured calibration, a starting calibration point. We took a measurement after the logger was deployed for a while. So we know what that value is. We looked it up in our logbook, and that was 456 microsiemens per centimeter. And the temperature at that time was 25.8 degrees C. And here, the measurement time, we can correlate it to a data point in our data file. We were recording from August 30th to September 10th. We did our grab sample at 1 p.m. or 1300 on the 30th after the logger had been recording for an hour. So we know that's nice and stable. So we'll correlate those numbers to that data point. We also did an ending calibration measurement with that same meter when we went back to the site on the 10th of September, and that value was 497 microsiemens per centimeter, and the temperature at that time of the water was 25.6. And we're going to correlate that. That was taken at 12:52 p.m. So we're going to correlate that to this last data point that was taken before we pulled it out of the water and read it out. These loggers were read out using an optic base station and a computer, so we were able to leave the loggers logging. We just pulled the data off them and allowed them to continue logging. We will leave them out there for another month or two. So let's click on Create New Series, and you'll notice now we have a new series that is created called Specific Conductance, and now we can plot this data. Here is our conductivity data. We have our raw conductivity in this column, temperature, and our specific conductance, which we calculated using the data assistant. We can see that our conductivity was always fairly high, up in the 400s, between 490 and 450. Actually, we're up in the 500 range. And again, this is most likely due to there is a lot of organic material in the water at this pond. However, this could be an indication of a pollutant runoff as well. We're not exactly sure. We believe that more water quality testing should be done with some other instruments. We do know that some wells were tested in that area, and they tested for elevated levels of dioxin. Now that we have both of our data series processed and plotted, so here's our conductivity data, there's our dissolved oxygen data, we can combine these into one graph and save it as a HOBOware project file. We could save these now as individual project files. If you do not save them as projects, you'll have to go through that post-processing function again. So what I want to do is combine them into one file. So let's copy our dissolved oxygen data into our conductivity file, and we'll save that. So what I want to copy is I want to copy my created series, which is my adjusted concentration. So we click in the what's called the details pane over here, left click to select it, and then up here at the top of the screen I can say edit, copy series, and then go into my conductivity file and say edit and paste series. And we can see that that series is now included. Because we used a delayed start to launch both of these loggers at the same time, the data points line up with each other perfectly. So you can see we have nice 15-minute data starting at noon on the 30th of August. Go back to our dissolved oxygen plot, and I want to get the temperature from there as well. I'm not going to include the raw conductivity or the raw dissolved oxygen in that combined file, just to keep it fairly uncluttered. So again, edit, copy series, edit, paste series. There's my temperature. To be clear, I'm going to change this name to say temperature from DO logger. The way you do that is you select the series, and then at the top of the screen, or you can select it here and right click, edit, graph properties, and we can say temperature from DO logger. Done. And now you can see that it's given a name here. It's also reflected over here. If we want to make some other changes to make this a little clearer, we have a lot of black, we have some dotted or dashed lines here, so we want to make this a little bit clearer to be able to understand this data. First thing I'm going to do, I'm going to change this conductivity temperature to clarify that too. Graph properties, temp from conductivity. And I'm going to change that color, be a little bit more off blue, just to kind of show them from each other. Okay, so the DO logger is a darker blue, temp conductivity is a little lighter. Here's our low range conductivity. Let's see how we can make that look a little better. Again, this is in black, so let's make that a nice red color. There we go. And our specific conductance, if we say that, you'll notice it's a dashed line. So we're going to make that a solid line, and we're going to make that a nice bright green color. So there's that one. And then our adjusted, that's black, that's fine. Our temp from DO logger, that ended up being a dashed line, so let's change that to a solid also. Here we go. Okay, so that's looking a little better. We can kind of see what's going on. So just to review some conclusions that we came to from this data, basically we think the dissolved oxygen levels seem to be sufficient for the type of fish that are in this habitat. We think we see that the levels are between 6 and 9 or so milligrams per liter, which is fine. The conductivity levels seem a bit high to us. We're certainly not experts in water quality, but it may indicate that additional water quality monitoring is required just based on those elevated conductivity levels. Both of the loggers will be in place for another 2 months. After that, we will remove them. We'll replace that dissolved oxygen cap, relaunch both loggers with a longer logging interval, about every 30 minutes or so, and get them ready to, we're going to winter over them under the ice in the pond.